And you're live.
Hello everyone and welcome to our Introduction to Heat Pump Technology webinar this afternoon. It's great to see so many of you have been able to join us. I will very shortly be handing over to John to provide a proper introduction to the webinar, but I just wanted to share with you our agenda for today. As you can see, it's fairly busy. We'll be touching on the policy landscape, talking about the transition from natural gas to low carbon heating, and we'll also be looking at a range of different heat pump solutions that are available, and we hope you find this session useful today. We will be taking questions through the question and answer function. You can type a question in the box, and you can also like these questions to increase their ranking. We will be responding to them as we can throughout the session by typing responses, but we've also got a Q&A section at the end where our speakers will be able to respond formally to those questions that we haven't been able to answer. If we run out of time and we aren't able to answer all of the questions that come through, we will follow up with an email with written responses to those questions. We will also be sharing the recording and the slides after the session. So I will hand over to John.
Thank you, Sam, and good afternoon, everyone. I'm delighted so many of you are able to join us this afternoon. It's great to see so many HBF members on the webinar, and I'm also delighted that we're able to work with the Heat Pump Association to put the webinar on for you. Clearly, this is a very topical issue. A number of people interested in taking part today certainly shows that, but I think we've also seen that it's a topical question given the government's recent confirmation of changes to Part L of the building regulations for later this year and the Future Homes Standard for 2025. And in the work that we've been doing around the Future Homes Task Force and creating an environmental roadmap for the industry for the future, we've seen enormous demand in the last few weeks for the sharing of knowledge and information in relation to the Part L changes, how to meet the standards and the changes in technology, design and construction that will be involved in a practical and effective way. Great thirst for knowledge and sharing of information in that sphere. And we see this as also an area where it's going to be important for HBF and our members to collaborate with other parts of the construction sector, with the manufacturers and suppliers who are represented through bodies like the Heat Pump Association, because we all want to get this right. We know there are a lot of challenges involved, but the first place to start is actually improving our knowledge base and exchanging information and ideas. So I hope today is going to be a useful part of that process. It is fairly early in that process, but important nonetheless. And I hope it will also be the beginning of a very close working relationship for us and our members with the Heat Pump Association and their members in the years to come in this important field. So I think that's all I'd like to say by way of introduction. I hope you enjoy the webinar. We'd be interested in your feedback on it afterwards, and we hope to be doing more in this space in months and years to come. But with that, I'd perhaps hand over to Rory Matthews to begin the presentation around the policy landscape for heat pumps.
Thanks very much, John. And yeah, it's really great to be speaking to everyone today. So just a brief introduction from me. I'm Rory Matthews. I work for a professional services firm, Acuity Advisory Limited, as an economist, and we've been working now with the Heat Pump Association for the last few years, developing the HPA's policy work, and part of my role is sort of putting together the economic case for the changes and policies supporting heat pumps. So hopefully today what I'm going to do is just give you a quick 5-minute introduction to the heat pump policy landscape and where things currently stand, before we then pass over to some of the more technical experts rather than myself, who can run through the technologies and give you a bit of an insight into the heat pumps and how they work. So I just wanted to sort of start setting the scene with a few recent announcements. And I think the one that's really grabbed the headlines and attention has been the 600,000 heat pumps per year to be deployed by 2028 as part of the 10-point plan. That was a sort of big change, and having that target, I think, has really focused a lot of minds and made people realise the challenge that's ahead. And this has been doubled down on in the government's energy white paper, where there's a firm commitment to the use of heat pumps in low carbon heating. And I guess the reason why we're all here today is the building regulations changes and a firm commitment and a view that the government is anticipating that heat pumps are going to become the primary heating technology for new homes. Next slide, please. Thank you. So really, why has that come about? And it's all to do with the carbon savings that heat pumps offer. So I actually made this graph probably last year, and the grid is, continually decarbonising at the moment and becoming cleaner. And when I made this graph, heat pumps were already offering a carbon saving of around 65% versus the gas boiler per kilowatt hour of heat output that's produced. And on the right hand side of the graph there, you can actually see the potential using Bayes' projections for where the electricity grid will go for the savings that you might be able to see from air source and ground source heat pumps, which is around 95% compared to the current gas boiler, and potential for that to even reach net zero if the grid fully decarbonises. Next slide, please. The UK is sort of a laggard compared to many other countries, and really I just wanted to show that widespread deployment is already commonplace across many European countries, and that we're sort of slightly lagging behind. But from that, we've learned some key lessons and policy sort of mixes that can help to encourage heat pumps, including new builds, and how we can grow that market within the UK to begin to reach that 600,000 figure the government is targeting. Next slide, please. So we've done a bit of work on this with the HPA, and putting together a supportive policy mix is going to come from building regulations, it's going to come from subsidy support, it's going to come from regulation on installers. It's the sort of lessons that we've learned from across the different countries. And really we've thought about how that growth might look. And this graph is taken from the HPA's roadmap document, which we released towards the back end of 2019, where we thought about how the heat pumps can ramp up over the next few years to align with the CCC's ambitions of over 1 million heat pumps being deployed per year by the 2030s. And those of you that have got a sort of keen eye, you'll be able to see that new build is essential for the growth at the start, and we view that that is a really key market for scaling up the market to begin with for heat pumps. Next slide, please. So why new builds? Well, a lot of the rationale for that is underpinned by cost effectiveness, and research by the Committee on Climate Change has shown that heat pumps are around cost comparable to gas boilers and can even be cheaper in some cases in new builds already. And that this also avoids the need for costly retrofit at a later date, which would mean that if we did have to carry that out, the sort of decarbonisation pathway would be more costly in reaching net zero. So I think that new builds are viewed as sort of the easier place to increase heat pump deployment currently, especially compared to the retrofit market, and can help build the supply chain as we work towards that 600,000 number. Next slide, please. And then this is my final slide, and it's really just a sort of quick insight into the HPA's current work and where we think the priorities lie. So as well as sort of pursuing a lot of the policy work that I showed on that graph a couple of slides ago, a key focus for us is our work on installers. It's absolutely critical that the installers possess the skills, and there's the base of skills required to ensure that the heat pump market can grow, and that these levels of deployment can be reached. And this is, just a really key area of focus for the industry. We've been working recently and made significant progress on developing a new training course for heat pump installers, and we're hoping to launch that within sort of a few months' time, that really updates the content and hopefully allows a lot of current gas engineers or fossil fuel boiler installers the ability to transfer over and upskill to be able to install heat pumps and make the most of their skills already. So that's everything from me. Look forward to sort of answering questions later on. I'm going to pass over to Craig now to continue. Thank you.
Hello everyone, my name's Craig Dolan. I'm the product manager for Renewables for Valent. So in those terms, if it's not a control or have a flame in it, then it generally falls under my remit. And I just wanted to take the time today to share with you some of Valent's experiences in the new build sector and the development of low carbon heating. Next slide. Okay, so the UK home, since most of us can remember, new build has always been built around a gas central heating system for the majority of cases, and the supply chain has been built up over a number of years to supply that. And particularly ourselves in Valent, we've seen a big shift in the last 18 months as people start paying more attention to low carbon heating and particularly heat pumps. So, Valent, with our experience of being the first manufacturer in the UK to move from non-condensing boilers to condensing boilers, and all the investment in training and developing the supply chain to support that, we are fully aware and ready to support you guys in the further evolution of the heating market. So we're going to be working with a number of our partners, including the HPA, to build skills across the value chain to make sure that we can get modern low carbon homes. Next slide. So it is a system approach with a heat pump. So planning is absolutely key. And I will say that in our experience, the majority of new builds do work on an air to water heat pump. I know Phil's going to go into details on later with ground source, but for this instance, I'm just talking mainly about air to water heat pumps. So understanding your property and the use of your property, so the heat loss and the hot water usage, taking into consideration both internal and external pipe runs if they're required. The placement of the hot water cylinder is also something that needs to be considered, that has recently dropped out as the development of combi boilers has grown. The considerations for sound and designing for heating comfort as well as compliance. So it all starts on the paper, and making sure that you really understand the use of the property and the thermal dynamics of that property, and making sure you specify a suitable heating system for that property. Next slide. So outdoor unit placement on the on an air to water heat pump, design considerations. People are investing a lot of money when they buy one of their homes, so making sure that the outdoor unit fits within the setting of the property and becomes part of the external design, and it isn't considered an afterthought. And some simple points to consider if you're looking at an outdoor unit is to make sure that it's placed as close as reasonably possible to the property to minimize external pipe runs and increase the installation speed. Ensuring that the condensation has somewhere to run off as well, so you don't get an ice block forming underneath the air to water heat pump unit. Clearances for airflow and service access, and the use of covers. If you want to cover the unit for whatever reason, you can do that. You just need to ensure that the airflow is suitable for the unit. And there's always a little bit of worry around noise, but for context, most modern air to water heat pumps now are as quiet or quieter than a boiler flue, and I don't think that we've had any complaints about the noise of boiler flues. So just to give you some idea of context. Next slide. So the coordination of installation, and this is something that we've found to be critical on the jobs that we've been operating in. Training the installers, as Rory has mentioned, is absolutely critical, and to do that before the installation starts, as well as drawing and supporting the installer, as they do their first installation systems. And it's developing teams of installers. Like traditionally, you'd have your plumber and your electricity team, and they have to work closer together, particularly when it comes to the controls aspects. Traditionally, the gas engineer would install the boiler, and then the electrician would do the wiring and hang the control on the wall. and now they need to work a bit closer together to ensure that that control is commissioned properly and the system is set up. So one of the key learnings that we found was, confident gas installers maybe slightly too confident. They've been doing the job for a number of years and they know how to do heating systems. It's their job, but they've built in habits that are there for gas installations, and they just need to relearn some new habits that are suitable for heat pumps and low carbon. It's installing to design. Some of the stories I could tell you about the paperwork saying one thing and the actual install being completely different are quite shocking sometimes. The electrical installation, which I've mentioned, particularly with the controls aspects and making sure that you've got power to the external unit. Condensation, this is always something that seems to be forgotten, and a heat pump, particularly an air to water heat pump, can produce 3 to 4 times more condensation than a gas boiler, and that's because as you're taking the heat energy out of the air, you create water, and that will drop and fall out of the bottom of the unit. So you just need to make sure that that's got a suitable space to run away from, and it's making sure that one of the key findings that we've found is split responsibilities across the installation. I'm doing the heating install, I don't consider the controls and or the condensation or something to be part of the heating install. It's making sure that what you require as an end product is considered in the placement of the contractor. Next slide. And a warm home is a welcoming home. The warmth and safety is at the bottom rung of Maslow's hierarchy of needs. So we want this to be right, and we want this to work for the homeowner and for the developer. So the consumer has to be a key focus in that. So handing over to the family, making sure that they know how to use their heating and their hot water, what they can expect from a heat pump performance, and the benefits of the system. 0 emissions at point of use, having the clean air, and having a renewable solution. And we all want the heating system to be invisibly brilliant, and what I mean by that is we don't want homeowners to be thinking about their heating system. It's just there, it works. I'd much rather they be thinking about the handles on their kitchen units rather than the heating system. So moving forward, it's all about working together and building those skills and that value chain across the supply chain, and making sure that the heating system and the heat pump is fit for purpose in the new homes. And I think that's me, and I'll hand over to Phil.
Thank you, Craig. That's great. Thank you for that. Yeah, good afternoon, everybody. Thank you for taking the time to tune in. My name's Phil Hurley. I'm the chair of the Heat Pump Association, but also I'm managing director of NEBI Energy Systems. So this afternoon, I'm going to take you through ground source heat pumps, another type of heat pump technology, and just really go through the benefits of this type of technology as well, especially in new build. So probably what we haven't seen yet is how a heat pump works. I don't want to go too much, we haven't got all afternoon, but a heat pump works basically in reverse as your refrigerator at home. What a ground source heat pump does is that it takes low grade heat from the ground. Now, a lot of people get confused with the heat from the ground. It's not coming from the Earth's core, it's actually coming from the sun. So basically it's thermal energy which is stored in the ground, and we're taking that low grade heat out of the ground. Next slide, please. So there's various ways you can take that heat out of the ground. One of the most common ones is what we call a ground collector, where pipe is buried in the ground. It's buried approximately a metre down, a metre apart, and there's a medium inside that pipe, which is generally a water mixed with glycol, because it can go below freezing, and that is pumped through the pipe into the heat pump inside the house, and it takes that low grade heat out of that glycol and pressurizes the refrigerant in the heat pump to produce heating and hot water for your house. One of the disadvantages of ground collectors is you need a certain amount of land dependent on the size of the house and dependent on the heat demand of the house. So you may not have the actual land available. If you have got the land available, then it's an ideal solution. And the next solution is a borehole collector. This is where you actually use a drilling rig to drill boreholes. I would say an average house would probably be anything from around about 50 to 80 meters deep. That could be 240 meter boreholes or 180 meter bore, for example. 40 mil or 32 mil pipe close together into the earth. Depending on the size of the house, more boreholes could be included. Multiple boreholes for houses, shared ground loops is another option. So this is probably one of the most common, I would say, if we're looking at housing estates and mass housing. Another couple of common ones are lake collectors. I would say there's not many lakes round properties, but there is certain properties which have water nearby, which can take, the pipes can be buried in the lake, and you're taking that low grade heat out of the lake. And also, if you've got a high water table, next one please, Sam. It's an open loop collector. So this is where you can be taking, if you've got a high water table, you can take water out of the ground, use it through the heat pump, and then pump it back into the ground. So that's also quite a common one. But the first two I showed you, the ground loops and boreholes, are probably the most common. So next slide. So the opportunities for ground source heat pumps. So I'll just go through these. They're significantly more cost effective than many alternative heating fuels. They are very low carbon, better SAP ratings when considering environmental performance. One of the benefits of ground source is that because the pipes are in the ground, then they're unaffected by air temperature. So you get a pretty stable efficiency all year round. Very long lifespan compared to alternative systems. Okay, the unit is inside the house and the pipe outside is buried, and it has a minimum life expectancy of 50 years. We would say 50 to 100 years once that pipe is in the ground. It's very quiet. Okay, it's space saving. Okay, and this could be quite a benefit if we're going onto mass housing, large developments, maybe small houses on some schemes, semi-detached townhouses, where basically you may not have the room to actually site outdoor units. So space saving is also a very good benefit. And once the groundworks are completed, then there's really no specialist technology after that. Okay, it's very similar technology inside, just to an air source, just to a gas boiler. Okay, it's the hot and cold water and the flow and return heating pipes. One other benefit which isn't on there is once you've got the pipes in the ground, you have got an alternative for cooling. As we go into more insulated homes in the years to come, if global warming does become more prevalent, especially warmer summers, then cooling could become something that consumers demand. And by having ground loops or boreholes in the ground, there is an option for free cooling to use the heat pump. And that is not using the heat pump in reverse, that's using the cool water out of the ground in respect of passive cooling. So quite environmentally friendly. So there is challenges, okay, and challenges for deployment with ground source, and probably the big one is disruption, okay, and that may be probably more on new build, disruption to new build, where people have already got the gardens and roads and pavements. But on a new build installation, that you've got groundworks to be done anyway. When you have a new development, you're putting in the drains, you're putting in the gas mains historically, You're putting telecommunications in, you're putting roads in, you're putting pavements in, you're doing the footings, you're doing foundations. So putting the boreholes and drilling the boreholes and doing underground pipes can be done at that stage within the groundworks of it. So yes, it is a challenge, but it's not unsurmountable in the normal schemes of a large development. Yes, you've got upfront costs from drilling, and this is probably one of the when we look at ground source over air source, and this may be why air source is more prevalent, because it hasn't got the high upfront cost associated with ground source. If we take the upfront costs away, then the cost of a ground source is no different really from the cost of any other heat pump or air source heat pump. Consumer unfamiliarity, okay, a lot of people now hearing of air source, maybe not so much ground source, and space requirement if not considered from the outset. So really they are the challenges, but I would say the main ones are around the costs and the costs of it. On to the next one, please, Sam. So there is innovative ways of funding that, and what we say within the Heat Pump Association is taking the infrastructure and thinking of it as infrastructure, just like gas mains, just like electricity, just like telecommunications, just like drains. And there's also an opportunity there for encouraging installs by having it as an investment, and very similar to what we have with standing charges with gas and electric, is actually charging the homeowner a minimum cost per month to actually extract that heat, and that could be a minimum cost of say £20–25 a month to take the heat out of the ground. And for a investment company or actually a developer, okay, that is a long-term, low-regret investment, which could be there for 50 to 100 years. So the payback is fits in, and a low-regret investment, because once you bury the pipe in the ground, like I say, it's there for 50 years plus. Thank you, Sam. And that's my quick presentation on ground source. Hopefully you'll have some questions later, but I'll hand you over now to James Timms Harrison.
Good afternoon, everybody. Sorry, my name is James Timms Harrison, as Phil's just said, so thank you for that. And I'm a consultant for Acuity Advisory Limited, same company that Rory worked for that spoke earlier on. I do have a background in heat pumps. I used to be the heat pump product manager for Mitsubishi Electric. In fact, I am stepping in to take over from someone who's meant to be presenting now, Max Halliwell, who unfortunately couldn't make it. So, next slide, please, Sam. Okay, so I wanted to talk to you about air source heat pumps. Obviously, Craig has already spoken quite a lot about the technology and the design aspects and design requirements required when going into new build. And Phil's spoken about the vapor compression cycle a bit in terms of a ground source, but I just wanted to sort of highlight the differences with air source. This slide I think is really useful, and I really like it. It just simplifies it right down to the basics. The box in the middle being a heat pump, and the power being delivered to the property on the right hand side. So obviously this is the bit that we need to match up to the design requirements of the building itself. And this is what makes heat pump technology. And I'm possibly looking at some of the questions here. You know, there's a lot of people that have a great deal of knowledge, but there might be some people here that don't. And I think it's important to just highlight why the government's backing this technology. And it's this green bit at the top here. And this is what's so important to this bigger story, is trying to understand the fact that actually a heat pump is able to harvest this renewable aspect, this kind of renewable air or heat that sits in the ground, and deliver that into the property. And what that means is we're actually only going to consume 1 kilowatt of electrical energy for every 3.2 kilowatts. In this particular case, obviously that varies during the year, but this is taking a reasonably good efficiency system, can deliver 3.2 kilowatts of energy or power into the building. Now, what that means in terms of national grid and government is that as we move to an electrified heating system world, and this is going to happen, you know, we've made some big commitments and put a lot of money into the grid to get it decarbonised. is this means now that rather than using electric resistive or electric storage heaters that give you 3.2 kilowatts of power for every 3.2 kilowatts of energy that go into it, is that in this case now the grid can be a third of the size than it would otherwise be required to be if we were to install electric heating systems. So this is why heat pumps have been chosen as the selected technology to move us towards this new world. And that's a kind of very simple diagram as to why, as to how that comes together. So if you go to the next slide, Sam. So as I said, yeah, Phil already spoke about the vapor compression cycle. I think there's some animations on there, Sam. I don't know if they all come up. Oh, there we go. I think there's a couple more as well. So what we've got here is the various components that sit within our heat pump unit, and to just highlight the differences between what Phil's already spoken about as a ground source to an air source, is this evaporating coil, this evaporating element of the heat pump cycle. And it's this bit that's interchangeable effectively for any type of heat pump that sits out there. Everything that's kind of on the right hand side of that evaporator coil is common amongst all of our heat pump technologies. It's this evaporator coil that we effectively manipulate to change the type of technology. And for this case, under an air source unit, it's a finned evaporator coil that we run our ambient air across to draw all of that nice latent energy and sensible energy that sits within the air and use it to warm up our refrigerant to run it into this cycle. And on the right hand side there, the heat exchanger, I've seen a couple of questions already come in around this side, is that what we're then able to deliver is water into the property, just like it would be if it was a boiler system. And we've spoken about things like, you know, what temperature water is going to come out of that side. It's important to say, yes, it is going to be a little bit cooler than perhaps what you might have been used to designing systems at, and that will mean that radiator sizes need to be thought about in that design phase. But it's no more, or in fact, no, it should be no less than what we should be doing for condensing gas boilers. I mean, Craig is working for Valent there, and I'm sure you'll thoroughly agree to this, is that to get a gas boiler to condense, we need to be at that lower end of the spectrum of temperatures to get the best out of a condensing gas boiler. And that's just the same with a heat pump. We want to get those temperatures as low as possible, and that does mean a design consideration in the design phase for the radiators in the system. So we go to the next slide. Oh, expansion about the last one. Okay, so I want to sort of put this into real terms. So this is a property with an air source heat pump sitting on the outside of it there. You know, I think, you know, visually, yes, there is an aspect to that there, and I think Craig spoke about this. It's a consideration for when you're designing your properties, and you know, there's lots of ways that it can be designed into the design of the property rather than just stuck on the outside of it. And we'll get better at that as we move forward. But there's a few other parts to this I just wanted to sort of talk about. And I think one of the other things that's come up again on the questions that I've seen coming through is things like, you know, what about ambient temperature? Can it work at low ambient temperature? What about noise? That kind of thing. Now, I think it's important to say air source heat pump technology has been around for a long time. And throughout all the manufacturers that sit across the HPA, I don't think anyone's got technology that wouldn't be able to work down to sort of -20, -25 even with air source heat pump technology. So, you know, for the likes of the extremes of what we might see in the UK, let's say -15, it's well within the limit and the capability of these units. So I think that's the first important point to make there. And then noise is the other one. So, you know, the proximity of the unit in this particular picture to the neighbouring property, obviously in this particular case, might be quite a large distance, but I know that's not always the case with new build developments. So I think the important point here is permitted development. So can we meet permitted development under the rules? And the new generation of units that are coming out now, and I think someone asked a question about this, about sound levels. The sound power levels are coming out around about 50 to 58, I think, roughly, just generally speaking, which would give you the sound pressure levels to meet your permitted development rights, sort of 3 to 5-ish meters. So what we're seeing now is air source heat pump technology that's coming in that is going to be able to allow you to place that unit, you know, within some really sensible places within the property boundary to still meet permitted development. Go to the next slide. So on this slide, we've just got some examples of some of the components that sit within the property. And as I say, Craig has obviously talked about some of the design aspects to this, so I won't try and go over the same ground. But we talked about the external unit, the monoblock unit that you can see there. Now, there's some elements to controls and handover and what the end user sees that I think is really important to this story. So that on the top left, there's a controller. So I guess I'd probably speak about this as the commissioning unit. This is the commissioning controller that engineers or installers will use to set the system up. And largely speaking, the end user doesn't necessarily have to interact with. And that's kind of the brains of the technology and the bit that needs to be set up. And what we're seeing now, there's a lot of manufacturers that sit out there, but what we're seeing now is a move to sort of trying to automate this now. There's manufacturers out there that can do this remotely with SD cards. You can load up through USB sockets, so you can sort of set up all this stuff in the comfort of your own office, let's say, and then the installer can go out and just plug in the relevant control settings for that setup in those particular properties. So that's on the control side, or let's say commissioning side. And sorry, Sam, if you could stand that side for us. And in the middle there, we've got cylinders, so pre-pumped cylinders, as they're known. What that means is it allows you to do things like the first fix. It allows you to run your electric cables and your interconnecting pipe work, and then keep all of the high value items installed at that last point rather than during the first fix period. So you can get your pipe sensors and stuff in your airing cupboard, and then bring in a pre-pumped cylinder at that last second fix point. And it means that all of this stuff's protected. You're not going to get it dirty or dusty or plaster all over during that first fix phase, which I think is a really important point when you're designing this sort of a system for new build. And then the last part on the right hand side, the consumer controls, we're very much moving towards the ability for end users to interact via phones and that sort of thing. And for the end user, they shouldn't see any difference in operating the heating system as they would do if it was some other technology. That could be whether that's a gas boiler or anything else. So I think it's important to say that, from the end user's perspective, that handover procedure should be relatively simple. The maintenance aspect of it can be handled by a maintenance team and the setup and commissioning, but the end user, the handover bit, should be relatively simple nowadays. Thanks, Sam. And then just lastly, just a couple of case studies. So the first one here is, and before I say that, just say about mass market. We talk about hitting 600,000. I think I'm right in saying there's around about 200,000, if not more, heat pumps already in existence out there. So we're not talking about a niche technology anymore. We're talking about a technology that's got a huge amount of units already out there operating with decades of working time beneath them. So but as we move to this mass market, year-on-year mass market in new build, I think it's important to think about where it's worked. And in this particular example, Royal Borough of Greenwich is gearing up to meet its net zero carbon emissions by 2030, and they're under a lot of pressure to move their buildings and new build into sustainable homes. And Ilk Homes, maybe there's someone on this call that's from Ilk Homes, I'm not sure, that they've moved towards modular housing design. And in this particular solution, what they've done, able to deliver, is a net zero carbon option for the householder. So they could come in and say, well, I'm happy to buy this particular house and pay an uplift fee on the property price to achieve low running costs for the lifetime of the property. So that little on cost by the end user and the selling price is able to deliver that net zero carbon home. So, and one of the technologies they use to achieve that is a heat pump. So yeah, quite an interesting case study. And then the last one, Sam, is quite often talked about is how do we make heat pumps work on sort of low rise apartment buildings. And there's plenty of technologies out there that smaller units can deliver the sort of loads that you'd have in those sorts of properties. 3, 4, 5 kilowatt units, and they can be located in the balcony design. So you can see there it's a kind of L shape around the side of the balcony, and the units are sitting in those that sort of balcony design. So when when we start to think about how we're going to deploy this technology in our design work, in that early phase of new builds, it can be done quite cleverly. So last slide, just final thoughts and takeaways for me. I think it is going to be a favoured technology, and low temperature heating is coming at us. It's coming at us whether it's going to be gas boilers or heat pumps. So I think it's something that we need to start thinking about sooner rather than later. And that's me. I'll hand over to Ian.
Thanks, James. Afternoon, everybody. My name's Ian Bevan. I'm the commercial manager at renewable heating at Daikin UK. And before I joined Daikin, I was at my own contracting business fitting heating systems primarily in the new build sector. And I'm going to just spend the next 10 minutes running through some other heat pump solutions that you could consider, focusing on hybrid or bivalent heat pump solutions. So Sam, I'm just going to look at who makes them, how does this technology work, and where can you use them. So next slide. So in simple terms, who makes them is, well, most manufacturers make some form of hybrid or bivalent solution. A number of manufacturers have purpose manufactured hybrid systems. So you have a dedicated indoor and outdoor unit. And other manufacturers make heat pumps that can work alongside a secondary fuel source, such as a gas or oil boiler. So in simple terms, most manufacturers manufacture a hybrid or a bivalent option. So next slide, please, Sam. So how do they work? I think probably the easiest way to describe how a hybrid or bivalent system works is to start thinking more about how much does it cost to generate a kilowatt hour of heat, rather than just thinking about how much do I pay for a kilowatt of energy. So in this example, we've used a gas boiler. So in best case scenario, a gas boiler runs at about 90% efficient, and that efficiency doesn't change very often. And that's being generous. We just use it more in the winter than we do in the summer. But in reality, how much do we actually pay for a kilowatt hour of heat from that gas boiler? So if it's 90% efficient, to get 1 kilowatt hour of heat out of that boiler, we have to put more than 1 kilowatt in. So around about 1.1 kilowatts in. So if you're paying £5 per kilowatt hour for your gas, that kilowatt hour of heat, because you need to put a bit more in, if Sam just clicks on one for me, is actually costing you per kilowatt hour for the heat that we're generating. So for 1 kilowatt hour of heat for that gas boiler, it's costing us nearly 6 pence per kilowatt hour. If you go on to the next slide, Sam. So if we look at a heat pump is a much higher efficient heat engine, and in certain instances, a heat pump can have a COP, or coefficient of performance, which is effectively the efficiency. So in this particular instance, if you're paying 15 pence, just as an example, for electricity per kilowatt, but we still want a kilowatt hour of heat out of that heat source, we only need to put 1/4 kilowatt in. So in this particular instance, that kilowatt hour of heat, the same kilowatt hour of heat, is costing us just under 4 pence per kilowatt hour. So at these conditions, and in this instance, the kilowatt hour of heat that we need to generate is more cost effective to generate it by a heat pump. If you click on the last slide of this explanation, Sam, unlike a gas boiler, efficiency of a heat pump, because we're using the heat out of the air, can vary depending on the flow temperature that we need to generate and the ambient condition. So we'll take the same heat pump, and now the COP has dropped down to 2.5 or 250. We're still paying the same price for our kilowatt of electricity, but this time we need to put 0.4 of a kilowatt in to get the same 1 kilowatt hour of heat out. So in this instance, that same kilowatt hour of heat is costing us about 6 pence per kilowatt hour. So you can see that depending on the heat engine and the efficiency of that heat engine, the kilowatt hour of heat that we need to generate costs us varying amounts depending on how we're going to generate it and the conditions we're going to generate it at. And this is where a hybrid or a bivalent system works. So Sam can just click onto the next slide for me. And there's a couple of animations, Sam, so if you just click through them. So what you see here is a typical heat curve, a heat curve for a typical house in the UK. So how the hybrid or bivalent system works is at the higher ambient conditions, when the heat pump is at its most efficient, we will just run the heat pump because it's probably more cost effective, both in terms of running costs and carbon, to use the heat pump. As the ambient condition drops, and if Sam clicks on the next one, we'll see that we can start to run, in some instances, depending on in hybrid mode, where we can utilize the heat pump and the secondary heat source, in this case a gas boiler. Then as the efficiency of the heat pump starts to diminish even lower at the colder ambient temperatures, then the secondary heat source can take over completely. So it could be the gas boiler or the oil boiler can take over completely. And that's because the balancing point of the heat pump, the efficiency of the heat pump, is moving all the time, depending on, as I say, the ambient condition, the flow temperature, and obviously the price of the fuel that you're using. So in a hybrid or bivalent mode, what we're looking to do is utilize the heat pump when it's more cost effective and more carbon beneficial to do so. In some instances, we can run the two modes together. And then finally, when it's the best time to do so, the fossil fuel system can take over. So that's how hybrid works. If you assume then that if we were using a boiler for the same heat curve, and that whole zone was red, that means where we're using the heat pump or hybrid, we're potentially saving running cost and carbon, because otherwise that whole graph would be red, and that would be 100% boiler. So whenever we can use the heat pump or hybrid mode, we're potentially saving on running cost and we're saving on carbon. So that's the principle of how a hybrid or a bivalent system works. If you click on to the next one for me, Sam. So in effect, we're either at heat pump only when the COP or the efficiency is higher than that balancing point. The heat pump can cover the majority of the load. We move into hybrid when the heat pump is struggling maybe to cover the load, but it's still efficient, and we can use the boiler as a support. And then finally, we'll move over to boiler when the heat pump COP or the efficiency is lower than that balancing point, and it makes sense from a cost-effective reason and to a degree from a carbon reason to move over to the boiler mode. So that's the principle of a hybrid or bivalent system. The next thing we're going to look at is where can you use these? And effectively, there's a number of options with a hybrid. We can use it as a standard combi boiler. And as I mentioned at the start, we have some manufacturers that will make a purpose-made hybrid system. So we have an integrated pump, and the heat pump runs the flow through the boiler, through your radiator systems, and the return back to the heat pump. When we're in hybrid mode, it brings on the boiler to supplement the heat pump. And obviously when we're in boiler mode, then the heat pump stops and we just use the boiler. And it works as a normal combi. So the combi supplies hot water, the heat pump and the boiler can supply heat. A lot of manufacturers can also supply a hybrid heat pump or a bivalent heat pump that can work with a third-party boiler. So an existing boiler or somebody else's boiler. It works on the same principle. We either use the heat pump to heat or we use the boiler to heat. And in some instances, we can use both. But this time it's not a single integrated pump. And so we have boiler or heat pump. And then finally, Sam, if you click on one slide, we can also, in some instances, use a hybrid system as a system boiler setup. So if we need additional hot water, as many of you house builders do in the bigger properties, and a combi boiler isn't enough to supply the hot water we need, we can add a cylinder, and then we can use the boiler and the heat pump in the same way, but we can either use the boiler to heat the hot water, or we can supplement the hot water heating by using the hybrid heat pump. So there's a number of ways we can use a hybrid or bivalent system as a combi with somebody else's boiler, or as a system boiler with a cylinder. So it gives us a number of options. So we need to think about where would we use them. And as we transition from this high carbon, high temperature, fossil fuel based heating industry that most of us know, we move to low carbon, low temperature, sustainable heating industry. I see hybrids very much as a transition technology for many consumers and installers and specifiers and even manufacturers to make the jump from what we've been doing forever to where we need to get to, certainly in the next 10 years. There is an opportunity for this transition technology. Consumers know boilers, they understand how they work. We can introduce heat pumps, and it means that the consumer can use the heating system in exactly the same way as they've always used a heating system, but the heat pump is adding to help heat and provide hot water. So it sort of gives us the best of both worlds, traditional boiler operation combined with advanced heat pump technology. It's ideal for many heating engineers because most of these hybrid or bivalent systems only need water connections. So there's no need for F-gas accreditation, making the install simpler and easier. In some instances, it can improve the SAT target emission rating or the dwelling emission rate, and this can be achievable with one heating system, i.e. a hybrid heating system. Certainly in Scotland, we've had instances where we can achieve the Scottish Silver standard using a hybrid system because the hybrid can contribute to the hot water generation and can provide at least 5% of the production from a renewable source. And it does give us an intelligent heating system and potentially allows us to deliver lower running costs because the system will aim to select a balance between gas or oil and electricity to help in achieve lower energy bills by comparing the energy costs and selecting the most cost efficient whilst not impacting the comfort for the end user. So that was a very quick whistle-stop tour of another solution, which is hybrids utilising a heat pump. And as I say, we've looked at where we can apply them and the benefits of applying them. So that was my whistle-stop cover of hybrid. I'll hand back over to Sam, I think, to see if we've got any other questions. Oh, sorry, maybe I'm handing back over to Phil.
Phil, sorry, you're on mute.
Thank you, Ian. We just got a couple of slides just to finish off because the technologies we're talking about now are technologies which are available now, and I think we're all on a journey of change in construction. And as we see new home dwellings, the insulation levels are going to become more and more, especially in the future, then new technologies may be needed or available. So just going to slide, Sam. So as homes become more and more insulated, then ventilation then becomes an important factor, and there is various heat pumps out there which do work on ventilation as a heat source, and that could be for heating or heating on hot water or hot water on a home if we get to passive house standards. So you're ventilating the necessary rooms, your kitchen, your bathroom, which you need to ventilate, taking that condensation air out, but instead of just dumping it to outside, you're reclaiming that heat to run the heat pump to produce more heating or hot water. So these are solutions as houses become more and more insulated, and very popular now on the continent, especially in Scandinavia, with timber framed homes and very highly insulated homes. Sam? And then another innovative ones are things like mixture of systems with PV and PVT. Okay, another way, if we saw with ground source is one of the barriers is the cost, and also burying pipes in the ground. There is certain technologies out there which have air collectors which can be put on the roof combined with PV. So you're generating electricity and then using that electricity, but combined with the PV is an air collector for collecting heat, which runs your heat pump, which is then contained in the house. So another innovative ways of getting heat to run heat pumps. So these are new technologies you're going to see coming over the years as the building regs become more and more tighter, and we're trying to achieve better and better standards for mass housing. Thank you, Sam.
Great, thank you, Phil. Thank you to all of our speakers. We've had 70 or so questions come through. We've been trying to respond to them throughout the session, but there were a few more than we'd anticipated, which is fantastic. We've got a few minutes left, so I might just touch on some of the most liked questions that came through. There were quite a few around some of the costs, and Rory has responded to those. So question around capacity of the grid to achieve the 6,000 heat pump target, and combining that with EV charging, and whether there's a need for reinforcement of the grid. So I don't know who would like to take that question.
I mean, I don't mind starting. Go on, Phil.
No, or James, or Amisa.
Yeah, I was going to say, I think there is a consideration there, and it is part of the big plan to start looking at the increased load that we placed on the grid, and a lot of the DNOs have started that process to start to see how it affects local infrastructure, and then at a national level the total generation capacity that's required. But I think it's also important to say that, you know, as we move to a renewable generated or generators, is that heat pumps can actually be part of a bigger solution, which is in fact sort of leveling out the peaks and troughs that exist on the grid. So they can be part of what's known as demand side response, and work on agreed contracts to actually deliver financial benefit to the end user, to be part of sort of cutting off those peaks and troughs on the grid, as generation can be sometimes at times of the day when it's not necessarily always useful. So if you could perhaps store that energy in the hot water, you can end up with what's known as a thermal battery. So yeah, I think heat pumps actually can be part of the solution rather than always being seen as necessarily a part of a bigger problem for the grid.
Yeah, that's exactly what I was going to say, James.
Another one here around the expected in-use life of an external air source heat pump, and what are the maintenance requirements for one of these?
Shall I go?
You know, Craig,
yep.
Yeah.
Well, from our point of view, we work on a life cycle of 15 years for an air source heat pump. We do recommend that it's serviced annually, but unlike a gas boiler, you know, it's not a legal obligation. It's just to ensure that you extend the life of that unit for as long as possible, and ensure the operation. So yeah, that's from a Daikin perspective.
Thanks, Ian. Another question around the capacity of the heat pump supply chain to deliver the 600,000 units per year. Phil, I know we had a conversation about this the other day. I don't know whether you'd be able to comment.
Yeah, and I think these are interesting questions because there's two things which keep recurring, and especially from Boris's 600,000 heat pumps. Okay, who's going to install them all, and can we manufacture them all? We've got to remember, we're not talking 600 are going to happen overnight. Okay, what we need is manufacturers. You're talking the manufacturers who we're talking to today are large international companies who are manufacturing thousands or hundreds of thousands of products all over the world. So if there's a demand for this products, then we will manufacture. It's giving manufacturers the right green light to actually produce the products for the market. And we only have to look at, if we look at air source heat pumps, for example, okay, basically an air conditioning unit, and there's absolutely millions of air conditioning units manufactured worldwide every year. So I don't think that's an issue as long as the right policy and time frame is for manufacturers to invest in manufacturing.
Great, thanks, Phil. And a question for Ian here around bivalent solutions, and how they might work with the proposal to remove gas from new build homes as part of the Future Homes Standard, and what the role for bivalence might be.
Yeah, I think there's a number of, as I say, I do very much see bivalent or hybrid as a transition technology. We are trying to transition this well-established heating sector, which we have to do, by the way, you know, from what we know and love of high temperature, high carbon over to low temperature, low carbon. And I think there's some transition opportunities with hybrid on, you know, in the interim over the next 10 years, but also depending on what happens, you know, with the UK's plan, and if hydrogen plays a part, there's a lot of things to consider there, and maybe hybrid or bivalent systems, you know, working in conjunction with the hydrogen supply is also another option, because we don't know how much hydrogen is, if it happens, how expensive it's going to be for consumers. and also how much impact it would have on carbon. If it's blended hydrogen, then a blended hydrogen boiler working in conjunction with a heat pump would significantly reduce carbon and allow you to manage those running costs. So I think it's a transition technology at the moment, but there is maybe a part to play if and when the UK and other countries decide what the position is with hydrogen. So yeah, I think there's a number of options for it.
Great, thanks, Ian. I think we're probably out of time, so it just leaves me to thank you all for joining us, and thank you so much for all your questions. We will review them all and share responses to them via email, and we will be sharing the slides and the recording of the session as well. So thank you all.